Alrighty, let's talk about kinematics in one dimension. The motion of objects, baseballs, automobiles, joggers, and even the sun and moon is an obvious part of everyday life. Motion was undoubtedly the first aspect of the physical world to be thoroughly studied, and this study can be traced back to the ancient civilizations of Asia Minor. So we're talking about your Greece, your Egypt, your Iran, Iraq, that Middle East sort of Turkey, eastern end of the Mediterranean. Those guys were into this back then. Although the ancients acquired significant insight into motion, it was not until comparatively recently, in our 16th and 17th centuries, that our modern understanding of motion was established. Okay, there was a guy, you probably heard of him, by the name of Aristotle. I think he was Greek. He had a lot of ideas about motion, and a lot of them were wrong. People believed him for like 1,500 years. We'd be a lot more advanced if we had believed him. I was just reading the other day, this is coming up here, many contributed to this understanding that, as we shall soon see, two individuals stand out above the rest. Galileo Galilei, weird having the same name first and second, and always goes by his first name, like Cher, and Isaac Newton, who's always referred to as his last name, which is kind of weird. You'll also notice that Galileo died in 1642, and oddly enough, Newton was born that very same year. I was just reading the other day that Galileo did not believe. How can the people know what causes the tides on the Earth, like the water tides? What causes them? The moon. We all know that now, right? Turns out Galileo did not know that and argued against it. I was just reading that the other day. And not only that, but the Australian Aborigines actually knew that the moon affected the tides. And they figured that out centuries before Galileo, the Europeans, figured it out. Interesting. The study of the motion of objects and the related concepts of force and energy forms the field called mechanics. Why did I say it with that little extra? Okay? You'll notice that it's bolded. Mechanics is customarily divided into two parts. They are kinematics, which is what we're talking about this unit, which is the description of how objects move, so things like velocity and acceleration and stuff like that. And mechanics has a second unit called dynamics, which deals with why objects move as they do. Okay? The theory, the forces. Weirdly enough, or oddly enough, Galileo was more into the kinematics, how they move. After he died, Newton came along and started figuring out why things moved as they did. So kinematics is kind of like the Galileo unit, and dynamics is kind of like the Newton unit. Okay? And again, this is all that sort of Eurocentric science, right? No one really knows some of the, for example, the Australian Aborigines, there isn't really much of a record about their kind of science, unfortunately. We start by discussing objects that move without rotating. Such motion is called translational motion. Have you done translations in math class? You know where you get the line and you translate it over? Right? It moves without rotating, right? So we're going to be talking about that. We'll be mainly concerned with describing an object that moves along a straight line path, which we call one-dimensional, forward and backward, or rectilinear motion. Grade 12 will study how to describe motion in 2 or 3 dimensions, okay? So, projectiles. Fun stuff. You see the rocket back there? If it's a nice day, we'll take it outside and we'll blast it off in grade 12 and predict where it's going to land. Grade 12. Okay, let's talk about speed. Speed and velocity are words we often use interchangeably in everyday language. You already know what's the difference. One's got a direction, velocity. In physics, we make a distinction between them. For now, we discuss only speed, which refers to how far an object travels in a given time interval. Remember, we're reviewing grade 10 here. If a car travels 240 kilometers in 3 hours, we say its average speed was 80 kilometers an hour. How did I get 80, Daniel? I use the formula. 240 is my distance. 80 is my, 3 hours is my time. 240 divided by 3 is 80 kilometers an hour, okay? In general, I think my sheet is slightly different than yours. In general, the average speed of an object is defined as the distance traveled divided by the time it takes to travel this distance. And this definition can be written symbolically as V bar is equal to D over T. Do you have that there? You're going to be using it a lot. Did you use it in grade 10? You did. What does the bar mean? Good answer. It's not right, but that's a good guess. D stands for distance, T is for time. The bar over the B is the standard symbol meaning average. Okay? Average. What does average mean? Like, you got 70 on one test, you got 80 on another, your average is 75. Average. What do they call it in stats? I think you guys know this already. The mean. The mean is the average, the median is the one in the middle. Right? Mean, median, and the mode. Close enough. Okay. I'm going to ask you a clicker question. Can you use V equals D over T? Here we go. Did it start yet? No. Yeah, I think it did. Okay. Right? Solving for the distance. V bar equals D over T. 11.5 is D divided by 4. How do you solve that? Multiply. Oh, I hate the triangle thing. Should I show you the triangle thing?
No.
I will show you the triangle thing. Yep. Is that right? Okay. Here's how the triangle thing works. If you're solving for, I have to do it up here because I have to put my hand over. If you're solving for B, you put your hand over the B and it's D divided by T. If you're solving for D, it's B times T. If you're solving for T, it's D divided by B. You know what the problem with this is? What did you say it was? I heard you say it. Yeah, did you say it? Maybe not. It's a crutch.
Oh, a crutch.
Yeah, it's a crutch. I mean, it's something to help you, right? And that's okay for some students. The problem is, here's a formula from grade 12. There is no magic triangle for that. It's going to be an octagon-shaped kind of mongoloid kind of weird thing. It doesn't exist. Okay? It's okay for grade 10. Grade 11 students, you need to be able to know how to solve this. You need to. If you don't, you and I need to have a discussion. This is something you learned in math. If you've lasted this long without really understanding what's going on here, you and I need to have a talk. It's time to learn. You can do this. It's not hard. How do you get rid of divide by 4? Multiply. When this divide by 4 goes to the other side, it becomes multiply. Okay? If you need help, I'll gladly help with that. But by the end of this course, you need to look at that and know exactly what to do 100% of the time. There can be no, I don't know how to do that before you start grade 12. Okay, let's talk about reference frames. I'm going to try, I got 7 minutes, and I know this is where I left off the morning class. I'm trying to get you to the same spot. Reference frames and coordinate systems. Might go to the bell today, Adam, is that okay? I might go to the bell today. Yeah. When riding in a train, you may observe a bird flying by overhead and remark that it looks as if it's moving at a speed of 20 kilometers an hour. Who among us has never sat in a train, saw a bird, and remarked, hey, that bird looks like it's flying at 20 kilometers an hour? Has anyone ever said that? Nobody ever says that. Not even me, and I'm like the king of the nerds. Okay. Do you mean it's traveling 20 kilometers an hour with respect to the train or with respect to the ground? There is a difference. Allow me to explain. Every measurement must be made with respect to a frame of reference. For example, while on a train traveling at 9 meters per second, you might notice a person walking past you toward the front of the train at a speed of, say, 2 meters per second. I need a volunteer. Come on up, Zach. Stand back there. I'm going to be sitting here in my imaginary train. Zach's going to walk past me at 2 meters per second.
I don't know what to do.
Whatever, doesn't matter. Okay. I say, gee, Zach, it looks like you're walking at 2 meters per second. He says, I am. Well, Boston's outside the train, on the sidewalk. How fast is the train going? 9 meters per second. stand still. How fast is that going right now? Standing still.
9 meters per second.
9 meters per second, because you're all outside the train. How fast is the train going? How fast am I going? 9 meters per second. How fast is he going? 9 meters per second. He's standing still. I'm sitting still. He's on the train. We're on the train. You guys are on the sidewalk. He and I are on the train. Sitting here. I'm not driving the train, but 9 meters per second. He's going at 9 meters per second. Okay, why passing? At 2. Hey, Doc, it looks like you're walking by at 2 meters per second.
I am.
There he is. He is. My question to you is, with respect to the ground, that person, Zach, is moving at? Type it in. With respect to the ground, Zach is moving at? If you've been paying attention, this is like a 2-second answer. Adam, question? Just stretch it. Okay. I'm giving you 5 more seconds. Enter an answer, Austin. Austin. Answer. Yay! It is not the wrong answer. It's right. And in fact, as Katarina and Christina pointed out, the answer's right there. Zach, come on back. This isn't up there, but stand up there. Or passing. Hey, Zach, you look like you're walking at 2 meters per second.
I am.
Thank you. How fast is he walking looking to you there, Lawson? To you, on the sidewalk.
This way, so he's going back to 902. But no, yeah, so 7.
How many people agree? Zach moving 7.
Wait, was he one?
Go back again. How fast? Stand still. How fast are he and I going forward? 9. Hey, Zach, you look like you're walking 2 meters per second.
I am.
Going 7.
Thank you. He's moving 7 to you guys. It depends on your frame of reference. It's always important to specify the frame of reference when stating the speed. In everyday life, we usually mean with respect to the earth. When you're driving at 100 down the highway, you're driving 100 kilometers an hour with respect to the earth. Adam, are you at rest right now? Are you sitting still? 100%. He's 100% wrong. Because I didn't say with respect to what? Because the Earth is spinning on its axis. Once every 24 hours it goes around. And every 365 and a quarter days it goes around the sun. And who knows how often the Milky Way galaxy is spinning around. He's moving like thousands of miles an hour. We all are. Hurtling through space. But to us, here on Earth, it looks like we're traveling through. Okay? If you ever get a speeding ticket, try to use this as your defense. But Your Honor, I was only traveling at 70 kilometers an hour with respect to that guy going that way. Doesn't say on the sign with respect to the Earth, does it? Yeah, good luck with that. Yeah. Don't blame it on me. Don't bring my name up in court. Okay. Blah, 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 blah. I haven't got much time. Do you guys know about the origin? It's in the middle. To the right is positive x. To the left is negative x. To the up is positive y. And to the down is negative y. Blah, 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 blah. You know what? I'll skip this part. We're done.